All right, guys. We're going to go through and start our last stats section today. We're going to talk about normal distributions. There's a lot more stuff in normal distributions that we could go through and talk about, but we're actually just going to go into them and just do a little bit of basic stuff. You guys will go more in depth next year. So let's go ahead and let's talk about normal distributions. So if we were to go through and we were to gather data for something, and here we're looking at heights of people, but if I gathered 100 samples and we went through and we made a graph, it would look something like this graph up here in our upper left. So let me show you guys where we're working here. So it would look something like this graph. We've got a middle value where there's going to be the mean or the median in those. And then the data is kind of symmetric around both sides. If you look, it's not perfect. Some are smaller, some are bigger, but the graph is pretty symmetrical to the mean and the median, which is in the middle, because it's got a high point and then both sides kind of slope off as we're going through. As we continue to get more samples. So this first graph, I only went through and grabbed 100 samples. If I went through and I said, hey, instead of 100, I'm going to get 1,000 samples, my graph might start to look something like this one here. Now, if you guys notice, instead of being skewed more on the left here, this one's starting to get a little bit more balanced around the middle. So these other bars are a little bit higher here, and it kind of slopes off to the right and kind of slopes off to the left there. And as that sample size continues to increase, so we had 100, 1,000, and maybe think, hey, this could be 10,000 samples here. You guys notice now the curve starts to look a lot better. So as we go through and we get more data, the curve kind of gets more and more symmetric as we're looking at that. If we were to go through and we were to measure the height of all of these people, if we could get the height of everybody, or we could get an enormous number of samples, like going up towards 1 million, something like that, the data would begin to resemble what we call the normal distribution. And you guys have seen this graph before. So this graph right here is the graph of the normal distribution. It's symmetric on both sides, left and right, kind of perfectly to the mean. In a normal distribution, one thing that's important, the mean and the median are equal. So when we're going through a normal distribution, our mean and the median are the same, and the data spread evenly on both sides. Many real-world data sets resemble normal distribution. If we look at heights, we look at test scores, we look at car prices, we look at lifespans of products, things like that. All of those things follow normal distributions. Not every data set follows a normal distribution. There's a lot of different kinds, but normal distributions happen a lot when we're looking at data. We use these to make predictions about a population based on a number of samples. So we're going to go through, we're going to look at data, we're going to look at some of the properties of normal distributions and things like that, and we'll do some practice problems. So, sorry, I'm going to switch over to tablet mode here. The empirical rule. If we go through and we were to look at a graph of a normal distribution, now this isn't going to be perfect because this is mine, but if we put a axis there, an axis there, and I'm going to do my best to kind of have a, oh, that's going to be bad. Let me try this again. Okay, so that's going to be my normal distribution. This is perfect, but that's going to work. We'll say that the mean is going to be right here, the mean / the median. Don't look at the example yet. Don't worry about that. The mean or the median is going to be that value right in the middle there, and the data is evenly spread on both sides. We can pretend that my graph is perfect. The empirical rule tells us things about where the data falls. So if on the bottom here, if we look at this, this is standard deviations. So you guys remember standard deviation was a measure of how spread out the data set was, and this would just be a number of population samples. Standard deviation was that thing that we went through and we found in the last lesson. Standard deviation told you how spread out your data was from the mean. So if we go one standard deviation to the right, and I go one standard deviation to the left, our graph is going to go from here to here. From one standard deviation below and one standard deviation above the mean, 68% of your data samples will fall. So 68% of my samples are going to be within 1 standard deviation of the mean. That's above and below. If we continue that out, we go to 2 and 2 below. Go in a different color here. Sorry, guys. So if we look 2 below and we look 2 above, and I'm going to go in a different color and write it over here, 95% of the data is going to fall within 2 standard deviations of the mean. And if you guys go through here and we go to 3, I'm going to draw these lines first because I changed colors. I'll fill the 3s in on the graph. 99.7% of your data is going to be within 3 standard deviations of the mean. We'll talk about it again, what that means, but let's write that down. So 68% of your data is within 1 standard deviation of the mean. .95% is within 2, and 99.7% is within 3. So again, what you're saying there is if I went through and I got 100,000 samples and they followed a normal distribution, 68% of those samples, 68% of 100,000, so 68,000 of them are going to be within 1 standard deviation below or above the mean, okay? 95% of those samples, so 95,000 out of 100,000 are going to be within 2 standard deviations of the mean, and 99.7% of them are going to fall within 3. Okay, so we're going to use that. We're going to look at that. We're going to use these rules so you guys remember these 3 values, the 68, the 95, and the 99.7, and we're going to use those to figure out some things about the data sets, okay? Remember, this is only true for normal distribution. So let's go through and let's do some problems. You guys are going to see one like this in your homework. These are the first things normal distribution. So they tell us that male adult heights in North America are normally distributed. So that normally distributed tells you that we're going to go ahead and we're going to use the normal distribution. They give us 2 values here. They told us that the mean is 70. They told us that the standard deviation is 4. So I want to use that same notation that we used in the last lesson. I know X bar, or my mean, is 70. I know sigma, or my standard deviation, is 4. So remember, sigma, that standard deviation, tells us how spread out the data is. Standard deviation is the square root of the variance. Okay? So they're going to ask us some questions about this data set. We're just going to use this information to figure it out. First one, what height is 2 standard deviations above the mean? Oh, and guys, I didn't mention, but go through, try to answer all 4 of these questions, and then come back and look at the answers. If they're all right, then you guys don't have to listen to my explanations, okay? So what height is 2 standard deviations above the mean? Well, they told us here that my mean is 70, right? So I want to be 2 standard deviations above the mean. Above, so that's going to be plus. So if I take my 70, which is my mean, and I want to be 2 standard deviations above that, 70 plus 8 is 78 inches. So they say, hey, what height is 2 standard deviations above the mean in this data set that I gave you guys? 78 inches is that height. We're going to use these problems to find some other values in a second. So that's why we're going through and we're finding these now. I know this sounds really, really easy, okay? Second one, what height is 3 standard deviations below the mean? So now they told us our mean was 70, and we want to look 3 standard deviations below. So 3 standard deviations below that means that we're going 3 underneath, 70 minus 12, 58 inches. So if they say, hey, what's 2 standard deviations above 58? What's 3 standard deviations below 58? Add and subtraction, not too bad. The reason that we want to do that is because we want to be able to identify how many standard deviations we are away from the mean or the median to see where data is falling, okay? So now we're going to go ahead, we're going to apply what we just did along with the empirical rule to figure out things about the data set. So now this next one, they say, hey, what percentage of adults, so that's what we're trying to find, what percentage of adult males are going to be between 66 and 74 inches tall? So our goal here, guys, is to go through and to figure out, hey, how many standard deviations away are these? And then we'll use the empirical rule to go through and figure out what percentage of the data falls in there. So here, I know that my mean is 70. So I know my graph is, or my number line, if you want to think it on the bottom, is about here. I want to go over here to 66 and over here to 74. And I want to go, hey, what percentage of my data is going to fall in that part? Now, they told us here that my standard deviation was 4. So sigma was 4. So let's figure out how many standard deviations above and below we are. Well, 70 minus 4 is 66. So that's going to be 1 standard deviation away. 70 to 74 is 4 as well. So that's 1. So we want to know what percentage of the data is going to fall between 1 standard deviation of the mean. Well, the empirical rule tells us that 68%. So 68% of that data is going to be within 1 standard deviation of the mean. So I know that 68% of US males should be between 66 and 74 inches tall. Okay. Let's do another one. Between 70 and 74. So here we're going to have to go through and look at what part of the graph we're looking at again. And I've already got this number line drawn above here. But I can go, hey, I want to go from 70 to 74. I just figured out that this was 1 standard deviation. So I'm going to call that 0 because that's the mean. So I want to know what percentage of my data is going to fall in this part. So from 0 to 1. So I'm not looking at the entire interval that I did on the last one. I'm just looking at half of it. So if we came back up to our graph again and said, hey, I know, and I'm going to erase this in just a second, but I know that 68% of my data falls right there. I want to know, hey, what's this part of it? Is basically what I'm going through and I'm doing. So we want half of that 68, right? So half of that 68 is going to be 34. So we knew from the last one, from the empirical rule, that that entire interval was 68, but we only had half of it. So we want 34% of our data falling there. So again, if I had 100,000 or there was, 1 million people that we went through and 34% of them fell in there, or 100,000, then we're going to look at 34,000. It's going to be between 70 and 74 inches, okay? Is it above 78? So again, let's look at where we're at, okay? I know my standard deviation is, or my mean is 70. I know my standard deviation is 4, so I got 74, I got 78, I got 82. We can go down this way even though we don't need to. So I know, again, this part is 68%. I know from here to here is going to be 95%. And I know from there to there is going to be 99.7%. I'm just looking at the x-axis on the graph now. And I said, hey, I want to know what percentage is going to be above 78. Above 78 is going to be this portion right here. So remember, they didn't say between 78 and 82 here. They said above 78. So we need to figure out what percentage of the data is going to fall above 78. Okay. So if we think about it, I know that 95% of the data is going to fall in this range. Okay. So I know I've got 95% in there. So I know the total that falls outside has to be whatever's left. So if I go through and I subtract that 95 from the 100, that gives me the 5% that's left total. So there's 5% outside of 62 and 78, but I don't want all of that. If they said, hey, what percentage is below 62 or below above 78, I would have 5%. But that's not what they asked me for. They asked me how much is above 78. So I actually only want half of that. So half of that 5% is about 2.5%. All of this, guys, is coming back to the empirical rule. So the empirical rule states that 68% of your data falls within one standard deviation of the mean, 95% within two, 99.7 within three. So they're going to give you guys problems where they're going to give you a mean and a standard deviation. And they're going to say, hey, how many standard deviations above or below is this? Where you'll just go through and multiply and add or subtract. And then they're going to give you guys some problems where they're going to say, hey, what percentage of the data is going to fall in this range? And it's up to you guys to kind of come up with the x-axis there and figure out where those percentages are going to be. I want to keep the video short. So really, really quick, if we're going to go through and say, hey, there's a data set that's got a mean of 20 and a standard deviation of, let's just say 5. And they say, hey, what percent of the data falls between 15 and 25? Or they say, hey, what percent falls below 10%? Go through and kind of set up the x-axis of that graph. So if we look at the bottom, I know the middle is going to be 20, and then go 3 standard deviations above and 3 below. So 1, 2, 3, 25, 30, 35, 15, 10, 5. And then look at what we got, 68%. 95%. And 99.7%. So if they say, hey, between 15 and 25, 15 and 25 is that right there? That's 68%. So 68% of your data is right there. They say, hey, how much of it falls below 10%? Well, hey, below 10% is here. I know that 95%, so I did the same problem we did last time, but 95% falls here. So if I just wanted below that, then I would mean that this would be 2.5 and that would be 2.5. If I said, hey, above 35, sorry, not percent, 35 is over here. I know 99.7% of my data falls in there. So if I want to get a value over there, that's only half of the 0.3. So that would be 0.15%. So a very small portion of the population would be above 35, whatever that was. So when they ask you guys to go through and do those problems, there's where you're at, okay? All right, take a deep breath. We're almost there. Last thing that we're going to talk about today is z-scores. Z-scores are a way to figure out how many standard deviations above or below a sample is. So it's a way for us to go through and to compare data points when we're looking at those. Z-scores are things that you guys are going to use a lot. With the normal distribution, we can actually use this to find probabilities. We're not going to do it in this class, but you guys will next year. And to find the probabilities using normal distributions, you find z-scores. So I'm going to give you guys a formula for z-scores, and we're going to go through, we're going to look at how to calculate them and what they really mean. And then I'll get you guys started on homework, okay? So a z-score describes how many standard deviations above or below the mean a sample is. That's all it is. A z-score is a number, guys. It's going to be 1, 2, 3. It's going to be -1, -2, -3. It could be a decimal. It could be one of those things. It's going to be the relationship between your data point to the mean, okay? So when you guys are going through and we're calculating a z-score, I want you to remember that each x sub I is one of your samples. And when we say x sub I, it's just going to change. I could be 1, 2, 3, 4. It's just those data points. So it's just the numbers. X bar is going to be your mean. And sigma is your standard deviation. Sorry, I didn't leave myself enough room here. So x sub I is your sample. X bar is the mean. Sigma is the standard deviation. The z-score, and this formula you'll need, so write it down somewhere. Z-score is your sample minus the mean divided by the standard deviation. So when you guys are going through and you guys are finding a z-score, the z-score is your sample minus the mean divided by the standard deviation. That one's important. Like I said, you'll need it next year when you guys take it. You'll need it through homework, all those kind of stuff. So make sure you guys know what a z-score is, know how to calculate one. The z-score, the z value is how many standard deviations above or below the mean. So let's go through and let's calculate some of those. And I'm going to go ahead and leave that formula up there so we can find it. The mean weight of newborn infants is 7 pounds. So if you guys have a baby, when people have a baby, the newborn infant, the mean is 7 pounds. So that's going to be our X bar is 7. They also tell us that the standard deviation is 0.8 pounds, right? So that means my sigma is 0.8. The data is normally distributed. So they're telling us that it's a normal distribution. They want us to find z-scores for these three weights. So remember, these are our x sub i's, 9, 7, and 6. I want you guys to go through, see if you can find the z-scores. Go ahead, do that, pause, and come back and check the answers, okay? Okay, so calculating for 9, we're just going to go through. Now I know that my x sub I is equal to 9, and we're just going to plug it into that easy formula. So my z-score, well, actually, before we find the z-score, remember that this z-score is actually how many standard deviations above or below the mean. So 9, we know that x bar is 7. So 9's bigger than that. So this z-score should be positive. So think about that. This value is above the mean, things like that. Just so we know, we think about that. So our z-score is our value, which is 9, minus the mean divided by the standard deviation. Okay, so 9 minus 7 is 2. 2 divided by 0.8. And if you guys go through and divide that out, 2 divided by 0.8 is 2.5. So 9, what that tells me, a baby that is 9 pounds is 2.5 standard deviations above the mean. So if we were to go through and we were to look at a graph and you guys were to go to look at something like that, you would have your 2, you'd have your 2.5, we would be somewhere in that range, okay? So that would be the number of babies or the probability or things like that that they're going to fall in that range. The z-score for 9 pounds is 2.5. Let's find it for 7. So now our x sub I is equal to 7. So to find the z-score, I want 7 minus 7 divided by 0.8. That's 0 divided by 0.8, which is 0. Anytime your value is actually the mean, your z-score is going to be 0. They say how many standard deviations above or below the mean is that value. If your value is the mean, it's going to be 0. Okay, last one, 6. So now our x sub I is 6. To find the z-score, we're going to do 6 minus 7 minus the mean divided by the standard deviation. 6 minus 7 is negative 1. Negative 1 divided by 0.8, negative 0.8. Oh, actually, that's not right. I did the reciprocal. Let me get a calculator out really quick. Oh, and I already had a value on my calculator. Sorry, guys. 1.25. So negative, oops, I'm losing it here at the end. Negative 1.25. So a value of 6 pounds is 1.25 standard deviations below the mean is all that means. We could go through and say, hey, what percentage of data is going to fall between these, and we could find these values. I only showed it to you earlier. We were doing the ones where it was the exact numbers. There's charts and things you can use to go through and define these values. Again, we're not going into it this year, okay? So you should be able to find a z-score at this point. You should know what a z-score is. A z-score is the number of standard deviations above or below the mean. Given a data point, you guys are going to go through, and they'll always give you the mean and the standard deviation. So these problems will always be written this way, saying here's the mean, here's the standard deviation, find the z-score. So you guys take your data point minus the mean divided by standard deviation, okay? Last thing, so interpreting these z-scores. So we're going to go through, we want to know what these z-scores mean, and we want to figure out what the actual use is for them. So let's pretend, and you guys can tell I was writing this problem up this morning. You took 2 tests the week before our school year was ruined by this godforsaken stupid virus that is making me go insane because I want to go out and do things and get my kids out of the house so they stop yelling at each other and can do things besides play Roblox and watch YouTube. Anyways, you scored a 70% on your English test. So we took 2 tests that last week. You scored a 70% on your English test. you scored 62% on your math test. Your English test had a mean score of 76 and a standard deviation of 4. Your math test had a mean score of 60 and a standard deviation of 3%. Which test did you do better on? So normally you guys would look at a problem like this. You'd say, oh, I got a C on the English test. I got a D on the math test. So obviously I did better on my English test, right? We're not talking about an overall grade here. I want to know how you did in proportion to everyone else. One thing you guys will learn a lot about in college when you guys go through classes is curves. Teachers will grade things on a curve, and that curve is usually a normal distribution where they'll go through and they'll look at all your test grades and they'll go, okay, they lump up here in the middle. And sometimes in a math class, that could be a 50%. And your teachers will go through and go, well, 50% on the test was where most people made. So I'm going to make that a 70 and kind of score from there, depending on those. So when you look at your scores based on a test, you guys can't necessarily really do this in class because you don't have this data, but you actually want to look at how you did in proportion to everyone else. That's actually going to tell you what you did better on. Okay. So let's go through and let's find a Z-score. So let's find the Z-score for English and let's find the Z-score for math. Whichever one of those Z-scores is higher is going to be the test you guys did better on. So English, they told us our X sub I, or your data point, was a 70. Got a 70%. That's not bad. The median, or the mean, I'm sorry, mean or median, because it's normal, was a 76, and sigma was 4. So to go through and to find that Z-score, we're going to go through and we're going to do your data point minus the mean divided by 4. That's negative 6 divided by 4, which is negative 1.5. So although you got a C on that test, you're actually 1.5 standard deviations below the rest of the class. So even though you got a C and you might be happy about that, if you look at yourself in comparison to everybody else, you're not doing quite as well as you thought you were. Let's do the same thing for math. Your score on the math test was a 62. So our X sub I here was 62, but the class average there was a 60, and our standard deviation was 3%. Okay? So now let's look at that Z-score. I've got 62 minus 60 divided by 3. 62 minus 60 is 2. 2 divided by 3 is 0.66, repeating. So if we look at those two tests, or those two Z-scores, we'll go through and we'll look at that and go, okay, which one of those is higher? 0.66 is bigger than negative 1.5, so you did better on the math test. If you go back and you look at yourself in comparison to everyone else and you actually think about the difficulty level and things like that, you did better on that math test because your Z-score is higher there. So those are the 3 things that we're going to ask you guys to do on the homework right now. Again, guys, next year when you guys work with normal distributions, they're going to go do things. They're going to do the same types of problems like this, but they're going to say, hey, the mean weight of this is 7 pounds, standard deviation is 0.8. Find me the probability that a baby born is between 6.2 and 7.8 pounds. And if it was within 1 standard deviation, then you could just use the empirical rule and say it's 68%, but a lot of times it's not. So there's these normal distributions and these charts you guys will use. But other than that, it's exactly what we've been doing. So if you guys can understand the empirical rule, you can understand how to find a Z-score, and you guys can understand what it means, you guys should be fine for everything you guys are going to do next year. All right, I'm going to go through and I'm going to post an assignment on Pearson. So you guys will have that. That's going to be your one for the week. We'll do Schoology conferences. I'm going to move them. So Denise came in last week and said that they were a little bit too early in the morning at 11. So I'm going to move them to 2 if you guys have questions. I'm going to post an assignment for this. And then later this week, I will post a quiz for you guys for the statistics stuff. And then we'll start personal finance. So we'll start winding down, or we'll be done with the hard math and we'll start winding down and talking about some other stuff. If you guys have any questions, reach out on Remind, send me an email. One of those things, make sure you guys get the assignment done. I miss you guys and I will talk to you later. Okay. Oh, that's the wrong window. Sorry. Don't read my meeting notes. That's the wrong window too. I'm having trouble this morning. Screencastify.